Hi. Today I am going to talk about observational time delay. I know you have no idea what I am really talking about. Don't worry. I will explain how we are understanding things surrounding us. We humans have 5 senses: touch, sight, hearing, smell, and taste. Here, sight and hearing is mainly used for communicating and understanding far things that we can't touch. We see some things by the help of light, and hear some things with the help of sound waves. We know sound is not fast as light. Because of that, sound makes some delay in communication compared to light. For understanding delay of sound, let's talk about lightning. When lightning happened, we will observe light at first, and after some time we can hear the sound of lightning. Similarly, light have also a speed limit of 299,792,458 meter per second. Because of that, light also make delay in communication. That delay in communication caused by light is called observational time delay. Let's check delay of light between 2 points, which the points are not moving. Those points have zero velocity. Let's call those points A and B. And distance between A and B is equals d. Then how much time will light takes to travel from A to B? C equals velocity of light. D equals distance between point A and B. D equals time taken by light to travel from A to B. Then equation of time taken by light to travel from A to B equals D divided by C. From here we understood that point B observed point A t time slower. If anything happens on point A, it will reach point B after time t. For example, if 2 of them are standing on point A and B, the person on A wave her hand. The person on B only realize after light travel from A to B. There is a delay of communication between them. That delay is observational time delay between them. In this case, delay is d equals d divided by c. Let's look another example. Here point A and B are 5 light minutes far away. We place 2 clock on each point A and B. The real time on both clock is 10:05. But when we observe from point A, clock's time are different. Clock on B will be 5 minutes slower than clock on A. Similarly, when we observe from point B, clock on A will be 5 minutes slower than clock on B. Now I think you understand how distance affect observational time delay. On next section I will explain how motion affect observational time delay. Bye for now. Thank you. Hi. On previous section, we talk about observational time delay and how distance affect observational time delay. Now we are going to talk about how motion affect observational time delay. Don't worry. I will explain slowly. Here point A is moving towards point B with a velocity v. Did you see that before light reached point B? Point A moves slightly towards B. Distance traveled by light from point A initial position to point B equals ct, where c equals speed of light and d equals time taken by light to travel from point A initial position to point B. Distance traveled by point A equals vt. Remaining distance between point A and B after time t equals d. We are going to calculate observational time delay effect when point B observe point A. B observing A with the help of light. Before light reach point B, point A change position due to velocity of point A. From the diagram we will get the equation ct equals vt plus d. Ct is distance traveled by light. Vt is distance traveled by point A. D is remaining distance between point A and point B. From the equation we are going to take d to one side, then we will get d equals d divided by c minus v. Then observational time delay experienced by point B is d equals d divided by c minus v. Now I am going to compare reality with observation of A and B. Did you see the real time and position of A and B? The real time is 10:06 on both A and B. But when point B observe A, on clock on B show real time 10:06, but clock on A show 10 o'clock. And position of A observed by B also not real. It is past position of A. When observed from A, B is at real position because B is not moving. But time is not real. Time on A is 10:06, but time on B is 10:01. Now I think you got the effect of motion in observational time delay. We couldn't observe real position and time of object in motion due to observational time delay. Did you see that everything we observe with light is past, not the present things? The observation time delay changed with direction of velocity. That I will explain in next section. Bye for now. Thank you. Hi. On previous section we calculate observational time delay when point A moving towards point B. Now we are going to check what will happen when point A moving in different direction. Look at the diagram. Here point A is moving one direction. And light is moving in another direction. Angle between the velocity of point A and light equals theta. After time t, the real distance between point A and point B equals d. Did you see distance traveled by light equals ct? Where c is velocity of light. And distance traveled by point A equals vt. Where v is the velocity of point A. Did see the triangle? Using properties of triangle we are going to create an equation that d equals root of ct whole square plus vt whole square minus 2cvt square cosine theta. By solving this equation we are going to calculate observational time delay observed by point B. Take time t to one side, then we will get d equals d divided by root of c squared plus v squared 2cv cosine theta. Here point B observe point A t time slower. That d equals d divided by root of c squared plus v squared 2cv cosine theta. Now we are going to compare four different cases. When theta equals 90 degrees. Observational time delay observed by point B is t equals d divided by root of c squared plus v squared. When theta equals 0 degrees. D equals d divided by c minus v. When theta equals 180 degrees. D equals d divided by c plus v. When velocity of point A equals 0. D equals d divided by c. Now we are going to compare reality with observation of both point A and B. Look at the diagrams here. Vt equals 3 light minute. Ct equals 4 light minute. D equals 5 light minute. Did you see the real time on both point A and B is 10:05? But when point B observe point A, time and position of point A is past equals 10:01. Similarly when point A observe point B, time of the point B is past equals 10 o'clock. Now I think you got the idea how light delay between 2 points when one of the point is moving. On next section I will explain how observational time delay affect when both point are in motion, and how gravity affect observational time delay. Bye for now. Thank you.